Welcome back to Daily LeetCode. Another day, another chance to load up the fryer, throw some LeetCode problems in, put in some spices, and cook up some delicious success. So we are back once again, still doing easies. We are rapidly progressing. I've also been working on a Discord bot for the Discord, and I think that should be done tomorrow or today. But it's going low feature list, MVP type beat, minimum viable product, and then we'll see where we go from there. But other things I've been thinking about, I'm going to try the sunlight alarm. So rowing is flames. I think I've rowed every day for the last 11 days or something, or 12 days. Whenever I got the machine, I gotta be honest, it is a dream to row. Okay, this is top 10 exercises created on the planet. It might be top 2, and it's not 2 as well. So I think the problem I'm experiencing, I need something to kickstart the day. The rowing, after I do the rowing, I think there's probably some information on this, but there's something about getting my heart rate up to near max in the morning that just wakes you up. I don't know what it is, but there's just something about it that kickstarts the day. The problem is I need a kickstart to get to the kickstart. And I think what that needs to be is sunlight. So I've ordered a Hue Phillips light bulb, and at a particular time in the morning, it is going to light up and just turn on basically. And I'm hoping that if I just do that, and I'm going to put the light bulb right here, right on top of my face, and then set it to pretty much gradually turn on. That way, I'll already be kickstarted. Because it's interesting, I'll lay in bed pretty much forever until I see some light, and then I'm like, okay, I'm up. The problem with the barcode alarm is that I scan it and then go completely back to bed. I also figured out a way around it, and I can just close the app. The devs need to figure out something, but I'm sure it's because of Apple's ecosystem that it doesn't really matter if you close the app. It kind of dies. Whereas I think on Android you can have background tasks, but on iOS I think you can have background tasks, but they're very, very, very limited. So yeah, I'm gonna try the bulb, and I'll report back on if the kickstart of getting to the kickstart works. But that should be ideal. I also woke up a little later than usual because I was on a binge gaming session, right? And that game indeed is Omega Strikers. This game is actually fire. So on cold turkey blocker, I may set it so that the computer just shuts off at 12. It may just shut off at 12. So I might do that just because I don't want to stay up late. But also, not stopping the game is too strong. So yeah, I'm gonna try that and then work on the bot as well. But that being the case, we have to jump into a comment today, and the comment is by Yasir Gauti. We are using C on college. When I'm trying to self-learn from YT, they're all using C++, so it's not the same. That's why I asked if I should learn C++ to get better, or just stick with my teammates on college and use C like them. That is a tough question. Honestly, I think your situation's a little special since you're just starting out. I feel like you should just learn what you're learning in college, because C is the foundation of a ton of stuff. So I feel like if you're learning C in college already, you might as well just learn more C. So if you can take some tutorials, I think the problem you might also run into is that I don't know if there's a lot of C tutorials on YouTube. There might just be C++, or good people pumping them out is probably C++. But if you can find some C ones, I know there's a lot of good C books. So if you could find a good modern C book that isn't too esoteric, has some good exercises, and you can just follow through and follow along, that would probably be ideal. That way, what you learn outside of the classroom is reinforced with what you do inside of the classroom, rather than you're learning something inside the classroom and then something outside the classroom that's different. Especially since you're just starting, it might be useful to abuse the synergistic effect of supplemental study. But I'm not too far along, but I think if that's probably what I would do. When we were learning C++ in college, I read a lot of stuff online that said, I should learn a bunch of these different things. And then I just decided that I would just pretty much take another C++ book that we had laying around at the college and just go through that, and that really helped a lot. I also had the compound effect. I did really well in some of those classes, so I think that might be the best route. That way, you learn in class, helps you get good grades. You also get good at it much quicker, and then you can graduate to C++. Maybe if you want to make something specifically in C++ or something like that. I think the other thing that's tough is pre-optimization, because you're asking if it's better to learn C++ or C. I feel like if we focus on just the fundamental aspect of grabbing those key intuitions, it might be easier, because pre-optimization is tough. And I think someone else wrote a post about this, how the brain has like a natural entropic property, that information that you think will be useful is automatically removed. Like, for example, with the advent of spell checking technology in pretty much every typing interface, it's kind of like we've all kind of forgotten how to spell, basically, because there's no need to. You can just kind of, on my iPhone, I can just swipe, between the letters, and even if I don't remember all the letters, it always figures out what I mean anyway. So if you learn C++, it might just be harder to learn because you're not actually using it outside of class. But if you learn C outside of class and you're already using it inside of class, it has like a synergistic loop effect. Hopefully, that's what I would do, but we might be different in that sense. But yeah, also, great, as always, take my advice with a grain of salt. But yeah, that's what I would aim for. We're a bit short on time today, so we're going to go with 50 minutes. 50 minutes. And we're going to jump into it. I think the array problem we were working on before was build array from permutation. And we got a chance to pretty much use there's an interesting follow-up on this very simple problem, which I think could be very useful to know how to do in the future. The question is, should we spend more time on it or move forward? It really remains to be seen. Should we spend more time on it? Can you follow? So basically, we just had to move each array into C. Should be mapped to the actual nums sub. So 0 here in this array means that num sub 0 goes in this index in the output, which is 0. In index 2, right, or the second index, right, we know that the number we should place here is actually nums sub 2, which is actually 0, 1, 2, 1. So the answer here is 1. Then 1, we get 1, right? For the 5, right, the fifth element in this array is 4, which pretty much gets placed here. The problem is there a way to solve it without using extra space? And I think our version is technically still constant space, just because the number's length is up to 1000 and every number is unique, which means for any arbitrary pretty much means that our input is always the same size, so our set or the map that we use is always going to be the same size as well. But I think they wanted one without, I think what they meant to say maybe is in place. Can we solve this in place? It's a little tough though, because if you move a particular number, for example 2 here, right, we know at index 2, right, the value 1 goes here. But if you do that, then we actually lose access to index 1's value, so we need to place, for example, value index 1 right here at 1, it would actually just say 1 1 because we just placed 1 here. We've already solved it, but the constant time version is a little crazy. Elements in nums are distinct. For example, if we have 5 here, what if we stored the index in the index before it? Pretty much when we swap in a number, we need to replace it. We need to still have access to its previous value. So at index 1 goes the value at index 5, which is 4. Now what if we put 4 in here, and then where 5 is, we put it where 4 is? Never mind, it doesn't make any sense. Yeah, I'm not sure how they did this in constant time. This must be like a crazy solution. Because if, for example, a later position in the array, say j, has a value num sub j equals I, then we're out of luck. equals I. Must keep num sub I intact. Num sub I is the value at index I. Say j has a value num sub j equals value at index I. We overwrote the value at I, num sub I, with num sub I already, so then we're out of luck. To accomplish this task, we're going to use the fact that if we have a number of the form a equals qb plus r, number of the form a equals qb plus r, where b and r are not multiples of q and r is less than q, then we can extract b and r with the following. B equals a divided by q. Q is integer division. Slash slash is integer division. We know that QB, when divided by Q, give us B. However, we still would need to get rid of the R slash slash Q will always be 0. Thus, B equals QB slash slash Q plus. R is equal to A mod Q. We know that QB is a multiple of Q. Thus is divided by cleanly, and we know that R is less than Q, so R is not a multiple of Q. Yeah, this is a crazy answer. This is a crazy answer. Intuition is that you can find some function to encode both the new value and the old value into the same value. You can reach constant space. Oh yeah, I thought of the same thing here by encoding the value into the array, but that wouldn't be constant space, because in the worst case, it would still be linear space, I think, because we would expand the number. I think it's no different than using parallel arrays. Yeah, this guy here is really broke it down. The intuition here is that you can find some function to encode both the new value and the old value. I think a better way to think about this is with the bits. We could encode the new value and the old value in the upper bits. And just encode between them. So what if we retried this problem, except we will retry it. Let me see if I can find. Someone said thanks indecision tree. Oh, the person who wrote this post is indecision tree. Now, what if we could write the code intuition here is can we encode two values into one value? I think that is the intuition. It's actually a pretty fire intuition to get from an easy problem. Two values into one value, one version. One way is a function a equals qb plus r or something like that. Could store original number in and we could store the original number as it is in the bottom 4 bits or bottom 6 bits, and then we could store the other number in the top 6 bits, because it said that our nums.length goes up to 1000, and I'm pretty sure JavaScript uses 32-bit strings, but I'm actually not certain. I mean 32-bit integers, maybe it's 64, but we'll just store in the top X bits. We need a number of bits to store 1000. That'd be 1, 2, 4, 8, 16, 32, 64, 128, 56, 5, 12. All this comes out to 1 plus 2 plus 4 plus 8 plus. Actually, we can just do 2 to the 6, 64, 8, 9 is 5. I'm pretty sure 2 to the 9th will get us where we want to go, but let me double check. 1 plus 2 plus 4 plus 8 plus 16 is 32 plus 64 plus 128 plus 256 plus 512 gives us 1023, which is actually perfect with some extra bits remaining. And this would actually be 1, 2, 3, 4, 5, 6, 7, 8, 9. So in this version, we would need 9 bits total to do that. Now, what are we encoding? So I presume, right, we have this array here. This is the original array. We basically want to go through and do a pass through, which will encode the value. We'll extract using the 9 bits at the MS at the bottom half. We'll use that. Right, so at num sub 0, at this index 0, what should go here is nums sub 0, the number at num sub 0. The number at num sub 0 is 0. So I think we'll have to do this in 2 passes. One pass, the first pass, will encode all the values into the array, and in the second pass, we'll remove the original value. So remove the LSB value and place it in the MSB. I think. So iterate through it once. We'd store 0, 2, 1, 5, 3. So in 0, we'd store 0 in the in the first pass. We'd store the value that actually goes there in the LSB. No, in the MSBs. So 0 would get 0. In 2, at index 2, we should store value 0, 1. So we'll store that in the MSB. And then at index 1, in 1's MSB, we should store the value. So I think we can write this out. The first pass will encode first pass encode in MSB. Second pass extract MSB and replace number. That way we'll have access to the numbers and the saved numbers. So the bits version, I think this will be very useful in the future. The first pass, make sure I'm still recording. I'm a little skeptical. This could very well still be useful. Second pass, extract MSB and replace number in array. So the first pass, if you want to encode it, you want to use the first 9 bits. So we're pretty much going to want a function encode, which is going to take a number and a value to encode. And it might just be simpler to call it the encodee. And this is also going to be a number, and it's going to return a number. So we're going to let val equal 5, and we're just going to return an empty array down here. We're going to let val equals 5 just to write a quick test for it. We're going to have the number 5, and in this number we're going to encode the number 1000. And then we should be able to decode MSB and then we'll have another function which would be called decode MSB, and it should take a number and it's going to pretty much extract the first 9 bits. So if we have a number num, how could we encode I think we could just use OR. For example, if we have something like 5, which should be 0011, no, this should be 5 because 1, 1, we have 1, 2, 4, so it should be 5. And let's just say we had a comma here. This is just another 4 bits. One, 2, 3, 4, 5, 6, 7, 8. Can no longer type. All right, so we have 9 bits each. How would we get another value up into the top MS, into the most significant bits. What if we just did that, right? And we ORed it with the value itself and did something like shouldn't that automatically, oh, that's not OR. No, wait. Bitwise OR. That actually would not work because the values at the bottom would just be merged into the LSB. Maybe what we want is something else. We want the string already pre-assembled. What we mean by what we wanted to pretty much, I think we can only load it in one way. So we want this pre-assembled basically. There's gonna be a lot of bit logic. No, we could OR it. We could OR it. If we have the number something like this, and then we shift it down, let's just say it has 5, 6, 7, 8, 9 bits, and we have, let's just say our value is always going to be length 4 total. We can just shift it down. We need to basically move it down 5, so we could basically do the length, which would be 9 minus 4, and shift it 5. We make a function called print bits. It's going to take a number, it's not going to return anything, and it's just going to do I is less than 32, I plus. Say stir plus equal num and percent num and masked with 1, and then we'll just do console.log stir, and then we'll also shift it down. I think this should actually give us the number in reverse. So we did, yeah. So I think we want to do, we did, for example, 5, 0, 1, or we did 6, no 5, 0, 1, no 6, 0. They both are the same either way. If we did something like 1, 2, 4, which would be 7, the answer we want is 0, 1, 1, 1. But if we did it this way, we would get 0, 1, 1, 1, get 1. 1, 1, and then 0. So we want to do, I wonder if there's a reverse. No way. comment this out for some reason. And then what I'm gonna print here, actually, I think we can just call print bits of 5. Okay. If I do, that's definitely not what 5 should be. If I did 7. Maybe it's 64. Oh, I'm going the wrong way. Maybe we want to shift it down. So if we have 0, 1, 1, 1, 0, 1, 1, 1, which would give us 7. We'd mask it with 1, and move it down, shift it right, then we could mask it again, shift it right, mask it again. Then we would get 1, 1, 0, and then we would still reverse it. Okay, this looks right, because I passed in 7. We get 1, 2, 4. So if we wanted to encode 7 at the other end up here, like this, we could just move it . Actually, this whole thing would be simpler . This whole thing would be simpler if instead of storing it all the way at the end, we just store the first 9 bits using the lower value and the next 9 bits using the higher value. That way, when we encode the MSB, we could just start at 0. Now, if I were to do something like this, let me just check something. If I do 1, I don't even know how to do a bit mask or a bitwise or. Oh, it's just 1 bar. If I do 1 or 6, do we get 7 when I print the bits? We do. I think we can encode it as simply as starting with encoded equals 0, or we do pretty much encoded equals, well, we want to encode the encodee into num. Do that, we'd start with 0, and we'd say encoded equals encodee, then we can bit shift the encode 9 bits that way, and then do encode equals encode bitwise or num, and return encode. Now if we encode 1000, so we have pretty much, we're encoding 5 would be our bottom number and 1000 would be the other number that we're encoding. We should be able to just do print bits val. We wanted to encode 1000. So we have 5 down here. 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh yeah, I think this is working. And to encode 1000, this looks right. But to make it simpler, I'm going to record a simpler value, like 512. So this looks right. So we encode 512. Then, if we want to decode the MSB, what we can do is just do we can actually just do we can just uncomment this. Console.log decode MSB, and we should get 512. Now for decode MSB, our value that we're looking for is stored 9 bits after the current value. So we would take num, this is already by value, so we would shift it right 9 bits. Then I think we could just treat the number as is. Oh my god, we got 512. Oh my god. This is gonna be a cheat code. Alright, this is an actual cheat code. This is an actual cheat code. Now we should just be able to encode the values. So the first pass would just be to encode the goal value into MSB. So let I equals 0, I is less than nums.length, I plus plus. From here, we just want to encode the value in. So we'll say nums sub I is equal to nums. Want to encode MSB, right? The number in nums sub I as the input, and the value we actually want to encode would be nums sub I. Now, if we print the array afterwards, the values should be ridiculous, but this should be okay, because if we do nums.for each num, and instead we just do console.log decode MSB, and we pass in num, we should get the answer. So for this, we should get the output 0, 1, 2, 4, 5, 3. Or maybe we won't. Oh, the problem is, yeah, we're technically changing the number, so we have to decode it technically. So we actually need a way, right? So we looked at it too simply. We're encoding, so with the bits, we're encoding. The lower number is the original number, and the higher number is the MSB. We're encoding MSB, then we're decoding MSB, but our values are still broken, which is why after 0, 1, we end up with garbage. And this is because we can see that this is true because we end up encoding pretty much our values are broken. So we actually need a way to, when we use num sub I, the value at that let's take it a little slower. If we start at num sub 0, we encode 0 and at the top. So we encode at for num sub I, we're going to set it equal to 0 encoded into a value that is already 0. For 2, we want to put the value at 1 at index 2. So we end up saying num sub I, which is num sub I, which is index 1, or index, which is a third index, we want to set it equal to or we want to encode it. We'll say num sub I, we're going to encode num sub I, which is index 1. Index 1 is already a crazy value. Basically, I think we basically want to decode the value at num sub I. But we want to decode the LSB. How would you decode the LSB? It's the bottom 8 bits. I think we could just take a number, let decoded equal 0, and we'll just iterate over the first 9 bits of number, and we'll basically just say decoded is going to be equal to num and 1, and we'll just say decoded, we're going to slide it down left 1, and the num, we're actually going to slide it down right 1. And then we should return decoded. Oops. Oh my God, it works. 0, 2, 1, 5, 3, 4. No, wait, no, it doesn't. Oh yeah, if we print, no, wait, if we print the nums, right, we're doing num sub decode LSB. I'm getting getting lost in the sauce because of the problems. One of these values has to be decoded. When we decode the values right now, they don't make any sense. We just get a bunch of nonsense values. So for 0, for num sub I, it's going to be set to 0, but in the MSB we encoded nums sub I. Issue is that num sub I could already be mangled, which means the value we want to take out of it we're like have 4 minutes left and the timer is making me mess up my thinking. We've solved this problem. I just need to stitch it together. I'm just getting a little confused because of the mere fact of the way the problem is set up is confusing me a little bit. The fact that I was setting num sub I equal to nums of num sub I is messing me up. Num sub I is equal to encode MSB. So I'm going to switch the test case we're looking at because this is just confusing. So I'm just going to remove case 1. That way we can just work with case 2, just now case 1. Then we encode MSB in num sub I think we want to decode num sub I. Yeah, I think we want decoded LSB equal to nums sub I. And then for this index, decoded LSB, we want to encode nums sub decoded LSB into the MSB, and then we should be able to print. I think we need to check that decode LSB works. I gotta go. We should be able to figure this one out tomorrow, and that's a wrap.